let's welcome our first speaker, Mr. K.V. Raman. Mr. Raman is a renowned water and wastewater treatment expert with 36 years of experience since 1987. He worked for Ion Exchange India Ltd and Chemion Engineering Agencies. He founded Ionic Engineering Technology Pvt Ltd, a family-owned business in Pune, India in 2005 and is its chairman and MD. He has extensive experience in designing, engineering, installing, and servicing various water and wastewater treatment systems, including turnkey projects. Today, Mr. Raman will speak on technological trends in water treatment. So let's welcome Mr. Raman.
Water is something, which is my passion and which I am involved in for the past 36 years. So helping create a sustainable, livable planet with innovation and water treatment is going to be the brief talk about, during this session. And as the population increases, so as the water consumption and wastewater generation. So India is a water stressed and a water mismanaged country. Whether it is a domestic water or whether it is an industrial water, water is not being used properly and it is mismanaged. A lot of water is getting wasted. We all have a water footprint, and there is a disparity in water consumption and water footprint between rural and urban areas. Infrastructure for providing good quality drinking water is very limited, and the need of the hour is to provide innovative water solutions to address and mitigate these challenges. So this brief presentation, I would like to make it very interesting and innovative, so that all people, whoever is watching this presentation or webinar, they find it useful. So let us not talk about, water treatment itself is a very, very poorly neglected area. And water treatment itself, we use a lot of traditional technologies which are 40, 50, even 100-year-old technologies which we are using. Now the time has come for us to rethink about different water treatment technologies which are available in the market, and see what type of an innovation can be introduced into these areas, so that the challenges of water treatment can be taken care of. See, for example, you take about water treatment, raw water treatment. That is the basic principle of water treatment. If you see the traditional technologies, so we use a multi-step process called coagulation, flocculation, and then clarification. So all the clarifiers, everything in a big municipal and infrastructure projects, they are all manufactured out of civil work, which takes a lot of time and it occupies a lot of space or footprint, I would say, to construct and then commission it. Then followed by traditional sand filtration and then chlorine-based disinfection system. These are the traditional approaches. Whereas the new technologies, what we are talking about, it should be water efficient. So when we say water efficient, not only it should treat water efficiently, it should also generate wastewater, because all the technologies, whatever I mentioned here, like clarifier and sand filtration system, they are going to generate more wastewater for the backwash and desludging operations. Whereas the new innovative technologies, for example, if you see a variable pour microfiltration technology, it is not a multi-step process, it is a single-step process in which direct raw water can be filtered without use of chemicals. Which chemical are we talking about? Are we talking about coagulation and flocculation? So variable pour microfiltration can be a better alternative compared to the traditional multi-stage process. And as far as disinfection is concerned, the traditional method of disinfection of water is by chlorination. So more and more companies and worldwide people are migrating towards chlorine dioxide, ozone, and ultraviolet based disinfection systems. People are using it. Now coming back to the desalination technology. Desalination, you all know that it is used for removing of excess salt from the water. So in water treatment, over purification and non-purification both are not good. You have to treat the water rightly to meet certain particular objectives. So desalination is one process where we are using seawater desalination, brackish water desalination, even wastewater desalination to make the water fit for our drinking and other general purpose use. So the traditional, if you look at it, the traditional reverse osmosis plants, there are plug flow design which was invented about 40 years back. So the recovery is very low and it is unpredictable operations and less reliable. It is not fully automated, more downtime, and a lot of issues are there with the reverse osmosis system, which is of conventional design. Whereas the innovative reverse osmosis system based on closed loop desalination or closed circuit desalination, they are completely automatic. It comes with real time remote monitoring and control technology, and you can go up to a recovery of 90% with a minimum 75% guarantee, and is flexible, simple, and reliable. So this innovative closed loop desalination membrane based technology is a better alternative compared to the plug flow reverse osmosis system, which can be considered by the infrastructure and construction industry. And the next alternative will be capacitive electro desalination technology, which is a non-chemical and electrical driven desalination process, which is a better alternative to the traditional reverse osmosis process. With this technology, high recovery up to 90% is possible. It is a tunable water quality. That is very important because you remove the water salt only as much as you need. Rest all the salts can be left to the water so that the water becomes more drinkable. Then you have the high energy efficient and treated water quality is better, and it is simple, flexible with the dynamic process control. So the capacitive electro desalination is one of the innovative technology which we need to adopt and implement to reduce the water consumption. Then third one will be disinfection instead of a chlorination and ultraviolet disinfection. Probably we can look into the chlorine dioxide disinfection, which is 2.5 times more powerful. So like ozone, chlorine dioxide, a gas, which is dissolved in water, which is 2.5 times more powerful, and it's very effective, and more importantly, it is non-carcinogenic because it is known fact that chlorination gives you a lot of carcinogenic disinfection products. So with adoption of chlorine dioxide technology, we can think about better disinfection technology. So by adopting innovation, we can revolutionize the water treatment in the industry so that water treatment itself will become more and more efficient. We can provide sustainable future for our younger or forthcoming generations. So you all know about decentralized water treatment and water management. Now the digital technology is available to monitor the water quality, measure the water quantity, and reduce wastewater volumes. So the digital meters with IoT enabling will be able to help you in optimizing the water usage so that we use the water properly. So in conclusion, I would say that we have got a great way long way to go about to adopt the new technology. I would invite all the construction and infrastructure industry to think about using the new technologies so that any water treatment, wastewater treatment system can be a prefabricated and pre-engineered unit and ready to deploy unit, rather than depending on conventional way of manufacturing new water treatment technologies. So with that, I would like to conclude this brief meeting, and any questions we can keep it later. Thank you very much.
Thank you, Mr. Raman, for the detailed talk on technological trends in water treatment.